We have already collected a sample of the filtrate from the API filtration experiment, and we have already used it to measure, through titration, alkalinity and chlorides. Now we are going to measure calcium hardness. For this, I'm going to use a dedicated titration dish, one that doesn't have any trace of phenolphthalein. The phenolphthalein trace, like I have in this titration dish, would give us a distortion in the blue color final point I will be looking in this particular experiment. Now the first thing I'm going to do is, I already collected the sample, I'm going to go ahead and put some water, in this particular case, the ionized water that we have here in our lab. What I'm going to do is see if there is any calcium present here. If there is any, I'm going to neutralize it first so I can tell for sure that the measurement I'm going to be doing in the filtrate is going to be very accurate. Here is the water. I'm going to go ahead and add 5 drops of the calcium buffer solution. This will go first. And this is actually 1 normal sodium hydroxide. So we know that by doing this, the pH of this solution is going to go up and facilitate the work of the color indicator. This is the color indicator. We call it Calvert-2 calcium indicator. We are supposed to put between 1/4 and 1/2 of a gram. So I'm just going to go ahead and make an eyeball measurement from experience. And I can see that this is already working, giving us a very intense blue color. This blue is very pure, and this tells me that there was no calcium at all in the water that I got from this bottle. So now I'm ready to go ahead and put the sample. I'm going to measure exactly 1 cc and get it in the titration dish. This is a dedicated pipette, 1 cc for accuracy. And we can see a color change here. This is no longer a pure blue. It has some purple. The colors are very pale, but definitely not the blue. So there is calcium in the filtrate. Now we are going to find how much by titrating with Versenate hardness titrating solution. The one I'm going to be using is 0.01 molar, in which 1 milliliter would equal 20 equivalents per million. I could use 2, 20 or 200, but because I don't have a clue on how much calcium I will have, I'm going to use the one in between, which is 20. So I'm going to titrate with a 5 cc pipette until I get that blue color again, indicating that I have practically scavenged all the calcium ions in solution at the time I was also measuring them. Here we go with Versenate. I'm going back to a greenish blue color, but I still see a trace of purple. This is the final point. Now I can have everything in greenish blue, no trace at all of the purple color. And I can see that I have used exactly 0.5 cc's. Because I was using 0.5, I was using actually 20 equivalents per million. Have to multiply 0.5 times 400, that's going to give us 200 divided by 1. The hardness in this particular fluid is 200 milligrams per liter of calcium. Now, if we had any zinc in this particular fluid, it would also show us calcium. But in general, in a drilling fluid, we do not have zinc. The only reason to read zinc in this particular titration, it would be in a zinc bromide brine, for example, that we use for workover and completion fluids. So this concludes our titration of the calcium content in a filtrate.